The first thing we should do for this lesson is to set our project units. In the browser, at the top of the tree, you will see the units. Mouse over the units and select the icon that appears to the right. In the Change Active Units dialog, you can select the unit type. These lessons will be in inches. If you are in metric, select inch and OK. All projects need to start with a setup. With the workspace set to Manufacture, select the Setup icon from the Setup toolbar. Setup is where you tell Fusion what type of manufacturing process you'll be using, select your machine, define which Fusion models are parts, which Fusion models are fixtures, set your stock size, and set your zero position. Let's start with the Setup tab. The Machine Group area in this dialog is for selecting a machine. If you or someone else has created a turning machine already, you can press Select and pick it from the local folder. If not, we can press Select to enter the machine library. From the Library panel, select the Fusion 360 library to select a generic machine configuration. In the Filters section, select Turning to limit the available machines. Select the Autodesk Generic Mill Turn Lathe, and then press Select. Selecting a machine automatically sets the Setup Operations type. If it's not already, set the operations type to Turning or Mill Turn, and set the spindle to Primary Spindle. Next, we want to set the orientation of the part. Most lathe spindles point in the Z+ axis direction. To set the orientation, select Z-axis plane and X point. Select any cylindrical face to represent the spindle axis. Flip Z-axis so Z+ points away from the front face. For now, we'll just OK this setup. Notice how it points to the left. Let's change the view. At the bottom of the graphics area, we have the Navigation toolbar. At the far right, there is a group for Synchronize Active Setup. In the pull-down, you have Sync View with Active Setup and Sync Visibility with Active Setup. Sync View with Active Setup changes to an isometric view of the plane defined in the active setup. Sync Visibility with Active Setup controls the visibility of any models that are used in the active setup. Enable Sync View with Active Setup. Now select the dot for the current setup. You can see how it changes to an isometric view of the turning plane. Let's go back into the setup. Right-click on the setup and select Edit. Let's talk about the Z-Safe parameters. These control the retract position of the tool. With the Z-Safe reference position set to stock front, set the offset to 1 inch. Since we only have one model in this project, Fusion assumes that is the model to apply the machining toolpaths. If you have multiple models, you can select which one represents the turning model to machine. We do not need to make any selections. The chuck parameter tells Fusion where the chuck or chuck jaws start. Again, you can set the reference position and how far to offset from that position. The chuck reference defaults to model back. I'm going to set the offset to minus 0.500 inches. Select the Stock tab, where we will define the raw material. If you mouse over the Mode pull-down, you can see from the tooltip the kind of options you have for defining the stock size and shape. For lathe parts, we would use one of the cylinder options. Use Fixed Size Cylinder if you are using a stock of a known size. Or use Relative Size Cylinder to let Fusion help you determine the size you need. There are also options for tubes, but that doesn't apply to this part. We will use the relative size cylinder option. Using the radial stock offset of 40 thousandths, we can add stock around the diameter. Set the front side stock offset to 100 thousandths for stock on the face. Next, we have the backside stock offset. Remember the chuck and chuck reference parameters from the Setup tab? The chuck face is 500 thousandths from the back of the model. So you probably want to make the backside stock offset at least equal to that, if not more, in consideration of the amount of material the chuck needs to clamp onto the part. I'm going to set it to 1.5 inches. Finally, I'm going to set the round up to nearest value to 250 thousandths. Now in the dimensions section, you can see the size of the billet we need for this project. Now let's go to the Post-Process tab. Here we can define the program name number. We have a program name number set to 1001. That's the O number that is normally displayed at the beginning of the NC program. This is common for Haas and Fanuc controls. We can leave this set to 1001. For the program comment, I could add a comment about this part or the setup. This comment will be displayed at the start of the NC program. Let's type in turning introduction. WCS offset is the work coordinate system offset that will be output in the NC code. So where this is set to 0, that will output the first available fixture offset. The number 1 will also output the first available fixture offset. So if you have a Fanuc or a Haas type control, you would get a G54. If I set this to 2, I would get a G55, and so on, incrementing up. Let's set this to 1. Once that's defined, we can press OK. So, we have told Fusion that we are going to be doing turning. We defined our raw stock size, set our machining plane, set our XYZ 0 location, program number, added a comment, and defined our WCS fixture offset. We are ready to start machining the part with our first toolpath.